We're looking at mole ratios. Looking at if I was given hydrogen gas and give 5 moles of hydrogen gas, how many moles of water can I produce? So if we're looking at mole ratios, how is one substance related to another? So again, here we look at, I've got CH4 plus oxygen gas is going to yield carbon dioxide and water. What type of reaction is this?
Combustion.
Combustion. Good job. All right, so how are our substances related? When we're looking at this, basically it's telling us, what is the invisible coefficient here?
1.
1. So for 1 mole of methane and 2 moles of oxygen, I can produce 1 mole of carbon dioxide and 2 moles of H2O. That's essentially what those coefficients are telling you. They're a ratio. For every 2 oxygens, it's a 1 carbon dioxide that's produced. All right, for every 1 CH4, 1 carbon dioxide can be produced in this equation. All right, so we're looking at those coefficients today to tell us those ratios. If we look here, here are some of our conversions. If we look at, we call it the mole train. Stop along the way is a different station. All right, so we know that the base for molar mass, and 1 mole was the mass of 1 mole of that substance. Avogadro's number, 1 mole is equal to 6.02 times 10 to the 23rd particles. Well, now 1 mole of one substance is equal to whatever your ratio, mole ratio based on your coefficients is. So that is your new conversion factor that we're going to talk about today. And we're going to use the coefficients in balanced equations. So these are the 3 blanks there when it says when converting to mass, we use what? When converting from mole to mass, we use the molar mass. When converting to and from Pam, we use what? 1 mole equals?
Avogadro's number.
Avogadro's number, 6.02 times 10 to the 23rd. And now, new today, when converting to new substances, we're going to use what?
Mole ratio.
Mole ratios, or the coefficients in a balanced equation. Remember I said we're going to update that flow chart. Right now, we have what's in the middle?
Moles.
Mole. And over here, we have Pam. And on the left, we have gram. All right? So here's what we have so far. In the middle, to get from Pam, 6.02 E23. And over here we have the molar mass, which is the molar mass of that substance. But now we've got to add another step along the way. We're going from moles of A, substance A, so we might have grams of substance A or molecules of substance A. All right? And I'm converting to substance B. All right? Mole of substance B. All right, and you need a conversion factor here. So, remember, what we want to find always goes on the top, right? So the coefficient of B, whatever that second substance is that you're converting to, over the coefficient of substance A. Whatever you started with goes under, right? Because we need to cancel. And what we're going to is going on the top. So coefficient B is what they want you to find. Coefficient A is the substance they gave you. All right, so that is your updated flow chart. So let's look at this. For example, how many moles of carbon dioxide, which is what?
CO2.
CO2, are produced from the combustion of 12 moles of ethanol. So here's where our nuns really matter. Number, unit, name. I'm given what? What did they give me?
12 moles of ethanol.
12 moles of ethanol. And I want to find what?
CO2.
Moles of CO2. Yes, carbon dioxide. Good job. So notice, if I don't keep my names there, I don't know what substances it is, then I don't know what coefficients to look for. So here I am, I'm at ethanol, and I want to know how many moles of carbon dioxide I can produce. So let's start with the same as usual. All right? What always goes in our top left?
You're given.
The given. All right? So they gave me 12 moles of ethanol. And I want to find what?
CO2.
Mole of CO2. All right? What goes up must come down. So moles of, what was up top? Moles of ethanol. Because I need ethanol to cancel out to be left with carbon dioxide. But I need numbers here. Where did we say those numbers come from?
The coefficient.
The coefficient. So see, there's your B and your A. B is what I want to find. What is the coefficient of CO2?
2.
2. What is the coefficient of ethanol? There's nothing, so what is it?
1.
1. 1 mole of ethanol. And you're done. You just need to multiply across. 12 times 2 is what?
24.
24 over 1 mole of ethanol. So 24 over 1. I am going to be able to produce 24 moles of what? What am I trying to find? Moles of
CO2.
CO2. Notice that is what's left after your numbers and or your names and units cancel. I'm left with moles of CO2.
Is this one of the easier lessons?
Yes, this is one of your easier conversions. Right? You're mostly all dealing with whole numbers. All right. So this is just walking you through it. If you were to go look in Canvas at the notes, making sure your equation is balanced, finding those coefficients, locating them, and plugging it in. All right. Yes, good question. Do you think it'll always be balanced for you?
Nope.
No, that's why we learned how to balance last unit. All right, so let's look at this one. How many moles of hydrogen are needed to completely react 2 moles of nitrogen? So, what did they give me?
2 moles of nitrogen.
2 moles of nitrogen. Remember, our first step is always to identify what my given and find is. So, N2. If you have a question, oh wait, what does nitrogen look like? Look in your formula. All right. Oh, it appears with a 2, so nitrogen is N2. All right, and what do they want you to find?
Moles of hydrogen.
Moles of hydrogen. All right, so find moles of H2. Well, if I look at this equation, I need to use the coefficients to go from mole to mole. Is this balanced? Do I have accurate coefficients to use?
No.
No. All right, so let's cut it in half and balance it. Over here I have 2 nitrogens and 2 hydrogens, and I have 1 nitrogen and 3 hydrogens. So what do I need to do to balance it?
Multiply that side by 2.
2.
Put a 2 in front, and now I have 2 nitrogens and 6 hydrogens. My nitrogens are good. What can I go back and do to the left?
3.
Put a 3 there, and now I have 6 hydrogens. Now, do I have accurate coefficients to use?
Yes.
Yes. All right. So, set up our table. And you're given 2 moles of N2. And I want to get to what? Moles of
Hydrogen.
H2. Yes. Moles of H2. Remember, what goes up must come
Down.
Down.
So I need moles of N2 at the bottom. And now remember looking at your flow chart.
And then you got your coefficients.
Yes, good job, Annie, using your coefficients. So my coefficient of H2 is what?
3.
3, and my coefficient of N2 is
1.
1. All right, so we want to know how much do I need to completely react, meaning nothing's left over. All right, so 2 times 3 equals 6, divided by 1. My moles of N2 cancel out, and I'm left with 6 moles of H2. How's everybody feel about this?
Great.
Good. You good? All right, awesome. So, here it is again in your notes. Is this equation balanced? No, so we needed to balance it first, and that's what we did. Then we used our coefficients so that we could plug it in and find our moles of hydrogen. Questions? All righty. So, let's look at this next one. How many moles of oxygen? Finding moles of oxygen are produced by the decomposition. Look, decomposition reaction started with one, broke apart into two different things. The decomposition of 6 moles of potassium chlorate. So I'm given 6 moles, and what's potassium chlorate? KClO3. And I want to find what?
Moles of O2.
Moles of O2. All right. In order to do this, I need a coefficient. Is my equation balanced? Do I have coefficients?
No.
No. So let's split it in half. I have K, Cl, and O. 1, 1, 3. K, Cl, O. 1, 1, 2. What do I need to do here?
2, 2, 3.
Yes, good job. Put a 2 here. 2, 2,
Annie.
6. Annie is on a roll today, so that means I'm going to put 2's here and a 3 in front of here. Great job.
Thanks.
Now we're balanced. Now, using those coefficients, I can plug everything into my table. All right? So, 6 moles of KClO3. All right? And what do I want to find?
Moles of
O2.
O2.
Moles of O2. Oh, let me write it over some. All right, and remember, whatever goes up must come down. So on the bottom, I need moles of KClO3 so that will cancel. All right, and what is my coefficient for O2?
3,
3. And my coefficient for KClO3?
2.
2. So I have 6 times 3 at the top, all right, which equals 18, divided by 2 on the bottom. So 18 divided by 2, I have 9 moles of, what is my units left? Moles of
O2.
O2. Good?
Yeah.
All right. So we had to balance this equation again. And here's our problem that we worked out.
I like the colors.
I like it. Thank you. So, now let's look at this last one here. How many moles of chlorine are produced from the reaction of 3 moles of fluorine with an excess of sodium chloride? What do you notice about this one?
There's an excess.
You don't have an equation.
Uh-oh.
Yes, you do not have an equation. So we know that what? Chlorine is what is being produced, right?
Yeah.
What are we reacting? The reaction of, let me use a different color for our reactants. The reaction of what? Reaction of
3 moles of fluoride.
fluorine with what? With this plus
Some sodium chloride.
sodium chloride. All right? So let's go ahead and write our reactants. Fluorine, which is what?
FL.
No.
F. And remember, it's a diatomic, so F2. Plus sodium chloride. Sodium is
NaCl.
Na plus 1, Cl minus 1, so those cancel.
Around.
Yields, yes. What type of reaction is this?
Synthesis. No, I mean single.
Single replacement, yes. Chlorine is what's going to be produced. Look, Cl2 plus, remember, non-metal or anion always switches with the
No.
anion, non-metal with the non-metal. So you end up with NaF. All right, so you see your F2 and your Cl switching.
Do we have to balance?
Yes, do we need a balance? Is this balanced?
No.
No, it is not. So let's go ahead and balance it. I have 2 fluorines on the left and 1 on the right. So what do I need to put in front?
2.
Let's put a 2 in front. So now I've fixed my fluorines, but now I have 2 sodium. So what should I go over here and do? 2. Hopefully you all remember this from Unit 4. Is my equation balanced now?
Yes.
Yes. Now, look at that. You're using old skills. Good job. We wrote our equation. We got our coefficients. Let's go ahead and solve. So they gave me what?
3 moles
3 moles
of fluorine.
of fluorine given. This is why it's so important to identify your given and find, because after all this, if you don't go ahead and identify those, you're so bogged down in everything else that just happened, you may get confused. And you want to find how many what?
Moles.
Moles of
CO2.
chlorine. All right, so given and find. Let's go ahead and draw our table. What they give us always goes over here, so 3 moles of F2, and I want to find moles of Cl2, and then whatever goes up must come down so that we can cancel moles of F2. So let's go and find our coefficients. Cl
1.
1, F 1, look at that one, 3 moles of Cl2, mole Cl2. So let's add to your flow chart. All right, so this is what your final flow chart looks like. Again, it's not hard. It's just the same thing duplicated with your bridge in between. We call that your mole bridge.
So just like double step.
Yep, because, good question, Ben. Now you're changing substances. And so you can't go to grams of another substance without that mole bridge in between, right? So here's some options. We may be given grams of H2O and just need to go to moles of something else, right? Or I may be given grams of H2O and need to go all the way to grams of oxygen.
It reminds me of an airport.
Yes, that's a good way of thinking of it. I said it reminds me of like the bus system in San Francisco. Like when you go and you try and read the routes and you follow the blue line and where it goes, right? So you need to just pick out where you're at and where you need to get to, right? You may be given particles and want to get to grams. All right, so you just look at where do I start, where do I end, and how do I get there along the way? All right, so that will help guide you through your conversions to make sure you don't miss a step.
So whatever you do on the bottom, you gotta get your moles.
Yes,
So let's say they give you grams, you gotta get the moles. They give you pen, you gotta get the moles.
correct.
And then you gotta.
Because the only way to bridge from, if this was water and we're decomposing it to oxygen, the only way to switch from water to oxygen is what? Our mole bridge.
So, like once you find the mole, you transfer the mole up there. Or what?
Yep, so once you find moles, you use your mole ratio, those coefficients, to convert to your new substance. Now that I have the moles of that substance, I can go wherever I want. All right? So this is like saying I'm trying to do a reaction and I've got water. If I bring this many grams of water, how many grams of oxygen gas would then be produced? All right? So let's take a look at some example problems. It's just like what you've been doing. You've just got a different path that you're following. All right, so let's look at this first problem here. How many grams of water? So that is my find. Grams of water are produced from the combustion of 25 grams of ethanol. That is my given. All right, so here's our table. Always start with what?
Given.
What I'm given, yes. Good job, Jack. 25 grams, and I'm going to abbreviate ethanol. And like Jack said, anything I'm given, I've got to get to what first? Moles. Well, how do I get from grams to moles? I'll use a different color here since I can't erase. Here's my blue. I need to get grams to moles. That's your first step.
Divide this by the molar mass.
Divide by the molar mass. Yes, that's why we call it the mole train, because it's each step along the way.
Where's the molar mass?
So
But it's
we've got to find the mass of ethanol. All right, we all know how to calculate molar mass. So here's ethanol. I calculated it for you. We need to go back and review that. Please let me know. So I got to divide by the molar mass, which was 46. All right, and there's 46 grams in what? 1 mole of ethanol. Remember, when we were just using our circles, what's it always? Once we put either molar mass or PAM on the top or bottom, the other one is always 1 mole, right? So now I'm here. This is what I just got to. Like, think of it, that's what we call the mole train. There's each stop along the way until we get there. So, closing the door, we're going to the next stop. I'm at moles. Where do I need to go to next? Moles. Mole to mole ratio. So, coefficient of F over coefficient of G. Well, what they asked me to find is water. That coefficient tells me the moles of water
3.
over the moles of ethanol. All right, and like Ben just said, moles of water is what?
3.
3. Moles of ethanol is 1.
C2H5OH.
C2H5OH. All right, so here's where I'm at now. I made it to moles of F. Close the door, we need to go to grams. Now that I found moles, now I can go either way I need to go.
Respect this.
So, on the top, I'm multiplying by what? Molar mass of
32.
my find, which is H2O. All right?
Uh,
So,
16.
they want me to find water. I'm going to multiply by the molar mass of, grams of H2O, which is hydrogen plus oxygen gives you 18. And that's 18 grams per 1 mole of water.
So it's 18.
Does everybody see what we did? Here was our conversion to moles. We used our mole bridge to get up. And then we have our multiplied by the molar mass.
How did you get
18. There's 2 hydrogens, 1 oxygen. 2 plus 16 give you 18. Just your molar mass. So this is what you should have plugged into your chart. This is it all nice and neat written. All right, here's your, look, grams of ethanol cancel. Moles of ethanol cancel. Moles of water cancel. And what am I left with? What they asked me for, grams of H2O. All right, so when I multiply across the top, 25 times 3 times 18, I get 1350. And then 46 times 1 times 1 is 46. All right, divide it, and we get 29 grams of water. What would be produced from 25 grams of ethanol. If I walked in the lab and that's how much ethanol I had, and I had an abundance of oxygen, that is all I could produce of water. Are we good?
Yeah.
See how it's just the same thing we've been doing? All right.
Mom?
So, let's look at one more example, okay? How many grams of NO are produced, so that's my find, by the reaction of 4 moles of copper? We've already got our equation. It's got coefficients. If you see coefficients, it's most likely already balanced for you. All right? So I'm going from what? Moles to
Grams.
grams. Notice, you can start anywhere. Now that we have the full chart, we can start anywhere. So we started at moles of given. I need to go to moles of find. And then once I get there, I'm going to grams of find. All right? So now, you can jump on the train anywhere and get off wherever you need to get off. All right? So moles, let's write what we're given. 4 moles of copper. All right? And I need to get what? 2 moles of NO so that I can find the grams, right? Jack, that's where you said we just need to get from moles to moles. So that's using our what? Look at your chart. Coefficients of find over given. So they want me to find, what do they want me to find? NO. They gave me what? Copper, Cu. So let's find those in our equation. Where's NO?
2.
2. All right? So I've got 2 moles of NO, and where's copper? 3 moles of copper. That takes me to right here. I'm at moles of F. Am I done?
No.
I need to get to
3 moles of copper. Oh, that's up there. Okay.
Need to get to grams. What's in this little center here? It says molar mass. So I need the molar mass of what I'm trying to get to. What do they want me to find? NO. So grams of NO. NO is 30 grams. So I'm going to put 30 here. And there's that many grams per 1 mole of NO. Anytime you're on those side pieces, it's 1 mole. The only time it's not is if that's what's given to you or that's what is your mole ratio. Yes, nitrogen and oxygen. All right, and then you're just going to multiply across, divide by the bottom. So let's look at, here's your multiply across. I get 240 over 3. And that gives me 80. How are we doing? Nothing new, it's just like some more steps and just kind of pulling everything together. Do we need to do another example? Raise your hand for yes. Do you need another example?
No.
If you're good, you may start. I'll go ahead and do another example. Please work silently while I'm doing another example for those who may need it. All right? Yes. All right. No talking.
Sorry.
No talking. All right. So how many moles of HNO3, that's what we want to find, can completely react with 5 grams of copper, 5 grams of Cu. That's my given. All right, so I'm over here at grams, and I want to get all the way up to moles. So I'm starting what I'm given, and then find what you're looking for on the find side. All right, so write what I'm given. I'm given 5 grams of Cu. And so grams to moles means I need to use my molar mass, so I'm using that bottom arrow. The mass of copper is 63.5. All right, so 63.5 grams of copper goes here, and that's in 1 mole. Anytime you're on the side pieces, you use 1. So now I got to here, I need to get to moles. That's when I use my mole bridge with the coefficient of F over the coefficient of G. My find and given. So, what do they want me to find? HNO3. What's the coefficient? 8. So I have 8 moles of HNO3 over the coefficient of my given. Well, what did they give me? Copper. And that coefficient is 3. All right, so 3 moles of copper. And now I'm done. That got to where I wanted to get. All right, check mark. And so we're multiplying straight across. Divide by the bottom. And when you divide that, this is what you should get. We want to do another one? I'm totally fine with doing another one. If you need another one.
Sure, just one more.
All right, let's do the last one. How many grams of NO, so they want me to find grams, are produced from the reaction of 6.35 moles of copper with excess HNO3? That excess does not matter. That just means I'm not limited by this. It's like saying I've got 36 eggs, but only 1 box of cake matter. That's the only one that's going to make it matter to your problem. All right? So we're going from moles of what they gave us. So find moles on the given side of your flow chart. And I need to get up to grams of the find. All right? So go ahead and write down what they gave you. So that's 6.35 moles of copper. And I'm going mole to mole. This is my first step. This is where I need to get to. And that was my coefficient of F over the coefficient of G. So what do they want me to find? NO. What's the coefficient? 2. 2 moles of NO. Over the coefficient of what they gave me. They gave me copper, and copper's coefficient is 3. So 3 moles of copper. So now I've gotten here, all right, but I need to get on over to grams. So then inside of this, you see molar mass. So I need to multiply by the molar mass because that's what I'm trying to get to. That is of NO because it's the molar mass of my find. Well, how much does NO weigh? Nitrogen's 14, oxygen's 16, so 30 grams. And that's per 1 mole. Yep, so then multiply across, divide, and that is what you should get.
Thank you.
I'm coming around to see if you need help.